Morning, wonderful Earth Science kids. We're going to be talking about glaciers today. Let's get into it. What are glaciers? Well, glaciers are snow and ice accumulations that are large enough to survive the summer melt. Glaciers are one of the most powerful agents of erosion known to man. I want to show you these ideas about glaciers. Here we have a glacier butting up against a forest. Who's the winner here? Nothing can really stand in the way of a glacier. A glacier could butt up against a mountain, and if there's enough ice behind it, it could go up and over the mountain, and it will really mess with the mountain. So a forest is nothing for a glacier. Two main types of glaciers. Alpine glacier. These are glaciers that form because the mountains are way up high and they get so much snow up there, comes down. And then sometimes you'll have whole continents that are getting more snow in the winter than can melt in the summer. So that would form an ice cap over a whole continent. So alpine glaciers form high in high mountains where snow accumulates to sufficient depth so that it's compressed, compacted, and recrystallized. Wait a second, that sounds a lot like a rock, doesn't it? And in fact, it is a rock. What kind of rock? Metamorphic rock. Bam. Look at that. Right? When you look at something like this, you see this U-shaped valley here. Right? You see that? This U-shaped valley. What carves a U-shaped valley? Glacier, always. Okay. Furthermore, down here, you see this lake that is looking a funny color. It's this turquoise blue, and that's because of the rock flour. Glaciers grind rock to a fine powder, much finer than you'd normally find. And when introduced into the lake in sufficient quantities and hit with sunlight, you get turquoise color, and it is beautiful. But if you see that, you know there weren't just glaciers in the past. There are active glaciers introducing rock flour into the water right now. So this would be the region of alpine glaciers. Those mountains stick up pretty high. So as snow accumulates and compacts, it's affected by gravity, it begins to flow. Look at that. You can so clearly see that ice accumulation is flowing downhill. Here's some studies that were done on glaciers early on. You can see in 1874, they planted a bunch of stakes across a glacier. 1878, the stakes had moved. Look how they've moved. They're moving faster in the center than at the sides, just like the stream. Friction holds it back. Now, depending on the flow of the glacier, look at how it moved there. So it's still flowing fastest in the center, but the topography of the land forces the ice to move. Now, also notice the position of the glacier terminus, at the end of the glacier has been melting back, even though it's been surging forward. How can that be? Like I said, it's melting back. It is never actually receding backwards. And indeed, all glaciers, pretty much all glaciers on the planet, are melting back at an incredible rate. One of the ways that we know that global climate change is happening at a rapid rate. So, again, glaciers move fastest in the center. Did we mention that glaciers move fastest in the center? This is the up and down version of it, though. And you can see it's moving fastest at the top for the same reason. Friction. Wherever there's friction, it's going to hold the ice back, and ice on top of it will flow over it. From an airplane, look at that. Look at that big tongue of ice coming down. Right? This is up in the ice fields, and this is the glacier sliding down from that.
As snow accumulates in a snow field, the weight causes the grains of ice to partially melt and refreeze. Once you have tons of snow on top of you, it will melt, refreeze. It allows the ice to flow over itself. So this becomes a mass that has been folded and refolded. So this is what the glacier looks like from underneath. Notice the person standing here. So you get the sense of this. They carved a cave under this glacier specifically to study it. And the sunlight going through the ice here lets you see how the ice is folded and refolded over itself over time. As the ice flows through the valley, the flow broadens the valley into a U shape. Glaciers are cutting all along the bottom and the sides. Wherever the ice is moving, it's cutting. Unlike a valley stream, the stream is only cutting in that one narrow area. Here, all that water is very slow to get out to the ocean, so it covers the entire valley floor and cuts the entire valley floor. Now, you might be thinking, ice. Well, ice is not harder than rock. How can ice cut rock? Well, if ice can't cut rock, how can the glacier cut rock? Let's look at this process. So sediments carried by the glacier causes the erosion. Glaciers carry sediments of all sizes. Some rocks can be enormous. The size of a house is not uncommon. Glaciers, there's no other agent of erosion that can transport such incredibly large sediments. If you see a rock the size of a house or the size of a car out in a field, it did not get there through flooding. If there's a high mountain around it, it could have been a landslide. It could have just rolled off. Without a high mountain around it, the only way it could get there is glaciers. So glaciers could pick up rocks by a process called plucking. First, the ice flows over an area. The ice melts due to the pressure. It refreezes around the rock that it just flowed over. And now the glacier moves, and the rock is embedded in the bottom of it. So the rock is what's going to cut the valley. So scratches in bedrock caused by glaciers. These are all, look at these scratches in the bedrock. They are crazy, and they all are lined up this way. So the glacier slid over the rock like that, and those are called striations. As an alpine glacier moves downhill, it's constantly melting. When the forward movement of a glacier is faster than the melting rate, well, it's going to be advancing. Conversely, if the forward movement of a glacier is slower than the melting rate, it's said to be retreating. As a glacier retreats, it leaves behind its load of sediment. The sediment that is left behind is an unsorted mixture of all sizes of sediment. The sediment is called till. Till is left behind in unsorted piles called moraines. So we name the moraines according to their position. Terminal moraine is formed at the leading edge of a glacier. It's the edge of the glacier. Terminal, it's as far as the glacier went. A lateral moraine formed at the edges or sides of a glacier. The medial moraine is formed in the middle of a glacier. Now, how would you form a moraine in the middle of a glacier? And this picture shows you. There's the terminal moraine. Look at the lateral moraines, the side moraines, and there's a medial moraine. So if you look here, two lateral moraines merging together, when two glaciers merge, will form a medial moraine. So that does make a lot of sense. The ground moraine is everything under the glacier. You have rock left everywhere. There's a picture that you would take from an airplane. There's the medial moraine, and you can see these glaciers form tributaries. There's 3 glaciers at least that we see merging here. So after alpine glaciers retreat, they leave behind some very distinct landforms. These cirques, horns, arêtes, hanging valleys, and of course the standard U-shaped valleys. So if this was the land before a glacier and this is the land during a glacier, now notice what happens to all these valleys. 2 glaciers in adjoining valleys are going to sharpen the land between them, forming a knife edge ridge called an arête. The glaciers all carving out the mountain make the mountain a very sharp edged or a sharp pointed mountain called a horn. And then you can have all these glacial lakes carved out, tarns, and see this huge valley glacier. The lowest these side glaciers can ever drop into is the maximum height of the valley glacier. So these valleys don't get carved out very far. So when all the ice melts, you have these hanging valleys that appear to be way above the main valley floor. So that looks rather unusual. Another close-up, so you have the horns when you have multiple glaciers carving up a mountain and sharpening it. The arêtes are the sides between two glaciers that get sharpened. A cirque glacier, every glacier carving into a mountain makes this bowl-shaped depression. So it leaves the depression behind it when the ice is gone, and these would be called cirques, and sometimes they fill with water, so they'd be cirque lakes. And here's that bowl-shaped depression. You can see it is very efficient at carving this out in the glacier. There's a hanging valley. There's a horn. 3 or more cirques cutting into a peak will sharpen it to a horn. And from a distance, we see an arête. Just like I explained, the glaciers on either side endlessly carving the high point of the valley between them into a sharper edge. As glacier flows across the land, features such as ice falls and crevasses form. Ice falls are features that form when a hill changes shape, or changes slope, rather. Look at that, the ice fall. You can see that the land is so steep there that the glacier just opens up. These are very dangerous because they form crevasses. And you can see this person climbing into a crevasse. Crevasses often have snow on the top of them, and they take people who are walking on them and make them disappear. So very dangerous. And that's what it looks like from down inside a cirque. Let's be careful out there. But glaciers are among the most interesting things you can see. So hope you learned something. Bye-bye.